Welcome everyone. So in this video lecture, we are going to study about uniform and non-uniform motion. Okay, we will look at difference between the two and how can we identify whether a particular motion is a uniform motion. Okay, so we will learn that in this video lecture. So let's start with the uniform motion. So uniform motion is any motion in which you have equal distance in equal intervals of time. So this equal distance in equal intervals of time, that's a characteristic of any uniform motion. So let's understand this by an example. So if you look at this car, it's traveling in this direction, right, and going from A to B to C to D to E. Okay, let's just look at this motion. As it goes from A to B, it travels 10 kilometers in 1 minute. Okay, similarly, it will go from B to C, it travels 10 kilometers 1 minute, and then C to D, same thing, and then D to E is another same thing. So as you can see in this motion, the car is traveling equal distance in equal intervals of time. So this type of motion is called uniform motion. Okay, what are other examples? Like if you are going in a highway in a car, and if you are having that maintaining a speed of, let's say, 70 kilometers per hour, which is, let's assume it's the speed limit of that highway, then if you maintain that speed throughout your, or in that you maintain your speed, then you are traveling in a uniform motion. Now if you pay attention, I have used the word speed, so let's discuss about that. In uniform motion, your average speed and your actual speed at any moment is same. And what I mean by that, so in this motion we just looked at is car is traveling from A to E. Average speed is what? Average speed is basically total distance by total time. Total distance is about 40 kilometers, right? Total time is 4 minutes. So average speed is 10 kilometers per minute. Okay, now if I'm looking at the motion between A to B, let's just look at that motion. A to B, the speed in that would be 10 kilometers by 1 minute, right? Because it travels 10 kilometers in that distance. It's again 10 kilometers per minute. Now if I look at the motion, let's take a motion here, C to D. Okay, so C to D, it's again travels 10 kilometers in 1 minute in that direction, right? So that's about 10 kilometers per minute. So one thing you would have noticed is the average speed and speed in any path I'm taking is the same as 10 kilometers per minute. So, and that's another characteristic of uniform motion, is the average speed of that motion of the whole journey from A to E is same as the speed at any moment. We have looked at few examples. You can look at any distance here in this whole journey, and then you will still find the same result. Okay, another characteristic of uniform motion I want to talk about in this video lecture is distance time graph in a uniform motion. In this lecture we will briefly talk about it, and in the subsequent videos coming up we will talk more detail what are these graphs, what we can calculate from them. But in this I want to give a glimpse and also show you one of the characteristics of uniform motion. Okay, so in a distance time graph, let's say this is kilometer, so this is distance, and this is time, so this is a minute. Okay, so if I am drawing these points A, B, C, D, E, so let's say A is 0, car has not traveled anything. Then B, car traveled 10 kilometers, right? In the C, car traveled another 10 kilometers in 1 minute, right? And then E would be here, and then that. All right, so if I want to connect all these dots, as you can see, it's a straight line, right? So in a uniform motion, if you plot it in a distance time graph, this line, the curve, or all the motion will be a straight line. Okay, as we have seen in this example. So that was the third characteristic. So just a refreshing here. So let's refresh here. In uniform motion, you have equal distances in equal intervals of time. Your speed and average speed is same, and in the distance time graph you have a straight line. Okay, let's move on to the non-uniform motion. So in a non-uniform motion, the object travels unequal distances. So this is important here, unequal distances in equal intervals of time. Okay, so if you look at this motion which this car is doing, if I look at A to B, it travels 10 kilometers in 1 minute. Okay, pretty simple. As it goes from B to C, it travels 20 kilometers in 1 minute. Okay, C to D is 30 kilometers in 1 minute. Okay, and then D to E is 10 kilometers in 1 minute. Okay, so as you see in this motion, the car is traveling unequal distances, right, in equal intervals of time. So n equal intervals times here is 1 minute, right? So this type of motion, when car is traveling unequal distance in equal intervals time, is called non-uniform motion. Okay, I hope that is clear. Let's look at more about non-uniform motion. So in non-uniform motion, your average speed of the journey of the object, or the journey of the object, is not equal to speed. Okay, in the uniform motion we saw average speed was equal to actual speed, but in non-uniform motion that is not true. So if I want to calculate average speed of this, so average speed is basically total distance, which is 10 plus 20 plus 30 plus 10, which is about 70 kilometers. Total time is 4 minutes. So this is about 17.5 kilometer per minute. Okay, now if I want to calculate the speed of this object as it goes from A to B, that would be 10 kilometers in 1 minute, right? So that would be 10 kilometers per minute. Same if I want to calculate this speed of this object as it goes from D to E. Same if I want to calculate speed of this object as it goes from B to C, that would be 20 kilometers in 1 minute. Okay, that would be 20 kilometers per minute. So as you can see, the speed of this object is changed. Average speed of this object is not same as the speed of this object as it goes from different points. Okay, so in a non-uniform motion, the average speed is not equal to actual speed of the object, and which is car here. Okay, let's move on. So another characteristic I want to show you guys of the non-uniform motion is distance time graph. In a uniform motion, we saw distance time graph was a straight line. Okay, in a non-uniform motion, let's look at what that curve looks like. So if I want to plot this, so point A, let's look at the points here. Point A is what? Let's say the car is starting from position 0, so that is 0. So point A is like this, 0 kilometer. Okay, and then 0 minute. Okay, point B is what? 10 kilometers 1 minute. Point C is 10 plus 20 is 30 kilometer, right? That's 2 minutes. And then D is what? 30 plus 30, which is 60 kilometer in 3 minutes. And point E is what? 70 kilometers in 4 minutes. Okay, now if I want to plot this, so point A is going to be here, point B is going to be here, right? Point C is going to be 30 So here point D is 60, so it's gonna be here, and point E is 70, it's going to be here. So if I want to join all these points together, okay, as you can see, right, but as you can see, the graph is not a straight line, which was in this uniform motion. Now it's more like a curved line. Okay, then the slope of that line is not constant, and we will talk more about the slope of the line in the next lectures. But what I want to make a point here is the distance time graph of a non-uniform motion is not a straight line. It's not a straight line. Okay, I think the example makes it pretty clear. Okay, so let's do our revision one more time between the uniform and non-uniform motion. So in a uniform motion, the object travels equal distance in equal intervals of time. In a non-uniform motion, it's not true. In that they travel unequal distance in equal intervals of time. Okay. In a uniform motion, average speed is equal to actual speed at any time. In non-uniform motion, that is not true. The average speed is not equal to actual speed. The actual speed is changing quite a bit in the non-uniform motion. In the distance time graph, uniform motion have a straight line. In non-uniform motion, that is not true. The distance time graph is not a straight line, it's a curved line. So I hope that made things pretty clear about uniform and non-uniform motion.